President Putin has ordered Russia's strategic nuclear forces to be placed on high alert.
The U.S. and Russia are developing nuclear weapons that make the decision to use them less difficult.
Experts guess that Israel has between 80 and 400 nuclear warheads today.
Iran could develop nuclear power within 2 weeks.
India has about 172 nuclear warheads, Pakistan around 170. Both can deliver them via missiles, aircraft, and submarines.
Welcome back to the channel, everybody. So the news these days is pretty frightening, with all the news coming out about how many countries have nuclear weapons and how they intend to potentially even use them. And I just really have one question. How do you build one? Let's see if Google can help us out. Well, I guess we'll never know. Now, in order to build a nuclear bomb, you need to first decide you want a fission or fusion bomb. To create a fission or fusion bomb, you're going to need weapons-grade fissile material such as uranium-238 or plutonium-239. Now, the thing is, most uranium found in nature is unusable for nuclear weapons or reactors in its natural state because it contains the wrong isotope. And since it's non-fissile, it's not going to be able to sustain a chain reaction. So to make uranium usable, you're going to want to increase the concentration of U-235 through a process known as uranium enrichment. Now, the most commonly used method for uranium enrichment is done using these gas centrifuges. They convert uranium into uranium hexafluoride gas, spin it at high speeds to separate the lighter U-235 from the heavier U-238, and thousands of centrifuges in cascades are needed to get this weapons-grade material. So let's say you have this fissile material. Now what you need to do is bring it to critical mass, which is the minimum amount needed to sustain a chain reaction. If the material is subcritical, the neutrons escape and the reaction fizzles out. The two main designs that solve this are either a gun-type fission bomb or an implosion-type fission bomb. A gun-type fission bomb, like the one used in Hiroshima, uses two subcritical pieces of uranium-235, which are kept apart, and one piece is fired down a barrel at the other using conventional explosives, and when they collide, they form a supercritical mass and start a chain reaction. In the implosion-type fission bomb that they used in Nagasaki, a plutonium-239 core is surrounded by high explosives arranged in a spherical shell. When detonated, the explosives compress the core symmetrically into smaller, denser sphere, reaching supercritical mass. A neutron initiator, e.g. polonium and beryllium, at the center emits a burst of neutrons at peak compression to start the chain reaction. Now, once the fissile material becomes supercritical, the first thing that's going to happen is that a neutron is going to strike the fissile nucleus, either U-235 or Pu-239. Then the nucleus splits into two smaller nuclei, which are fission fragments. Then energy is released, and more neutrons are released, and these neutrons strike more nuclei. Eventually, this process continues to happen with billions of fissions happening in microseconds. The result is a massive release of energy from a small amount of mass, as described by E = mc squared. The bomb would then release a blast wave, which is the shock front, then thermal radiation, then prompt radiation, and eventually fallout if the ground is hit with that bomb. Now, for a fusion bomb, also known sometimes as a thermonuclear bomb or hydrogen bomb, releases energy by fusing light atomic nuclei, like deuterium and tritium, into heavier ones. Fusion bombs are two-stage weapons, and they start with a fission bomb that acts as a trigger, and then that fission explosion ignites the fusion fuel, and special X-rays that are going to be used to trigger the next stage, which is the fusion secondary. Inside the bomb casing, next to the primary, is the secondary stage, and it includes fusion fuel, usually lithium deuteride, a solid compound, a fissionable spark plug, usually a rod of uranium-235 or plutonium-239 at the center, tamping and containment materials, often uranium-238, and foam or plastic to transmit X-ray pressure. One common design is the Teller-Ulam design. This is the conceptual sequence of how a two-stage thermonuclear bomb works. Now, there's a huge difference between the power of a fission and fusion bomb. A fission bomb has about 10 to 50 kilotons of yield, and a fusion bomb has 1 megaton or more, which is equivalent to 1 million tons of TNT. Some notable examples of these fusion bombs are Ivy Mike in 1952, Castle Bravo in 1954, and the Tsar Bomba 1961, which is the largest ever Soviet test. So to recap, Essentially, to make a nuclear bomb, you're gonna first want to get your hands on some uranium or plutonium and make sure that it's enriched, which requires some pretty huge factories to make. And then you have to shape it in just the right way so that you can use special explosives to start the chain reaction that you need. And then you need to know some advanced engineering to be able to like move this bomb and not just have it blow up in your face. And usually only nation states could really be able to pull this off, but truth is, I believe in you guys, and that's why I think you should like and subscribe, and I'll see you guys in the next one.